Professor McComb.
And I'm Professor Woods.
We built a calorimeter, and our experiment was to see what the effect of radiant coils have inside our pop can.
Designing and building a calorimeter that had a radiant coil in the can.
Alright, we tested the calorimeter with the coil first to determine the temperature. We then removed it to see if the radiating coil did have a significant effect, if at all.
And I'm Professor Stonham in partnership with Professor McComb and Professor Woods, and we're here to talk about our calorimeter. First, we started with a box.
Brought to you by McDonald's. Make it bacon for 99 cents. Always reserved. I'm loving it.
And then we layered the box with some cotton balls, and then we had a layer of newspaper with tin foil. Inside our box, for conduction, we have cotton balls, house insulation, newspaper, and cardboard. For radiation, we have tin foil and our radiating coils inside the can. And for convection, we put our box upside down to prevent heat from rising.
We put a radiating coil in our can to radiate heat off of it. Then we put holes in here to make oxygen get to the candle.
Experiment, we put 100 grams of water into the can and lit the candle and put the calorimeter on top and measured for 10 minutes the change in temperature. Then we took out the coils and did the exact same experiment without the coils to measure the difference in the temperature.
We found that the radiating coils did indeed have an effect on the heat of the water.
In the initial experiment with the radiant coils, it had a heat of 14.839 kilojoules. When we removed the coils, it had a heat of 10.45 kilojoules.
To design the radiating coils differently by making them bigger or putting more in the can, and also we could see if painting it black had an effect.